Alright, this video is just going to be kind of a clarification on the differences between when you add and subtract rational functions versus solving rational functions. So the first one, notice it says subtract. So the directions tell you what kind of problem you're doing. That's not usually the issue. And of course you know that when you subtract fractions or add fractions, you need a common denominator. So the first thing you want to do is you want to look at your denominators and make sure they're all factored. So always the first step, right? So factor, factor, factor. And the first denominator, x minus 1, is definitely factored. X plus 6 is definitely factored. But x squared plus 5x minus 6, we can factor that down. And that will factor down to x plus 6 and x minus 1, and be careful, sometimes the factors of 6 that add up to 5, people accidentally use 2 and 3, so just make sure you find the correct one. So I'm just going to kind of put a slash through this because I don't want to accidentally use that. I won't slash it so much in case you want to still see it. So then the second step, after you factor all the denominators and take out LC or least common multiples and everything, you want to find the LCD. So in this case, I can see that two of the denominators share an x minus 1, and then I can also see that this and this one share an x plus 6, and that takes care of everything. So my LCD is going to be x minus 1 and x plus 6. Then the third step, after you find your LCD, is to multiply the numerators by what they're missing from the LCD. Okay, so the first one has an x minus 1, but it's missing the x plus 6. So I need to multiply it times x plus 6. And I'll squeeze those in there and I'll rewrite this too. The second denominator has an x plus 6, but it's missing the x minus 1, so I'll multiply its numerator and denominator by x minus 1. And the last fraction has both the components of the LCD, so the 14 doesn't need anything. So now I'm going to simplify this so it doesn't look like such a mess. So I have x plus 2 times x minus 6. So I'm going to FOIL this out. So I'm going to get x squared plus 2x plus 6x plus 12 all over x minus 1 and x plus 6. And then I have minus 2x minus 2 all over x minus 1 and x plus 6. And then I have minus 14 over, I'm sorry about my space here, x minus 1 and x plus 6. So, I'll kind of squeeze that. Now I'm ready to subtract, and you need to be real careful. And I personally, you're subtracting a negative here, so you're subtracting 2x, but then you're subtracting a negative 2. So I personally take that and I change this to a plus, a negative, and a positive, like carry that subtraction through that entire fraction. The minus 14 you don't have to worry about because it's just one number. But then you just want to combine like terms all across the numerator since your denominator is the same, and don't drop your denominator, right? So I only have the 1x squared, and then I have 2 plus 6, which is 8. 8 minus 2 is 6, so I have a 6x. And then I have 12 plus 2, which is 14, and then minus 14, which is nothing. And then that will be over x minus 1 and x plus 6. And this one's a little bit tricky because now in your numerator, and this doesn't happen real often, you can factor out an x. And then notice that your x plus 6's actually reduce, and you're left with x over x minus 1. So this is an example of a subtraction problem, and the thing I want you to note is that after you find that common denominator, you don't want to drop the denominator, and I think sometimes people accidentally drop the denominator because they're used to doing that in a solving problem. Alright, this one is a solving problem. So the first step is the same as adding and subtracting. You want to factor out your denominators. So the first denominator factors down to x minus 4 and x minus 2. And the other two denominators are already factored completely. So then you're ready to find the LCD. So the first fraction, the x minus 4, is shared by the second fraction. And the x minus 2 is shared also. So your LCD is x minus 4 times x minus 2, and that takes care of everything in all denominators. Then the third step, and here's what changes from adding, subtracting to solving, is that you're going to multiply the numerator by the entire LCD and not by just what it's missing from that common denominator. So I'm going to take the negative 4 times the LCD. I'm going to take the 3, let me rewrite that. I'm going to take the 3x times the LCD, and I'm going to take the 2 times the LCD. And then you cancel, of course. First cancel things out, and then solve. So here you can note that the x minus 2's cancel and the x minus 4's cancel, so I'm only left with negative 4. With the 3x, the x minus 4's cancel, so I'm left with 3x times x minus 2. And with the 2, the x minus 2's cancel, so I'm left with x minus 4. And then it's just a simplifying process. So distributing the 3 through, I get 3x squared minus 6x. Distributing the 2 through, 2x minus 8. Combine like terms. So 3x squared minus 4x minus 8. I'll add 4 over to the other side. So this should be the easy part. And then I can't take anything out, so it's ready to factor. So this would give you minus 6 plus 2, which is minus 4, and that gives me negative 4. Then when I solve these, I get negative 2/3 and a positive 2, and then remind yourself that you want to always check those answers, because if it makes any denominators 0, that would be undefined. So look at the 2. If I put 2 up here, 2 minus 2 is 0, and that's not going to work. So I know 2 doesn't work. Negative 2/3 won't make any of these 0, so that one is fine. So don't forget to check for making denominator 0. So again, adding and subtracting, the steps involved with adding and subtracting is with everything, you're always factoring out those denominators and then always finding the LCD. Then you just have to keep straight when you add and subtract. You keep the LCD, so you adjust all the fractions so that they have the LCD, but when you solve, you actually multiply every numerator by the entire LCD and cancel out like terms. Okay, you try this last one. Pause the video and just make sure that you can solve this. Okay, so I factored this denominator to get x. I factored out an x, and then I noted that these two denominators had an x in common, and these two denominators had an x minus 3 in common, and that took care of everything. So there's my LCD. So then I multiplied every single numerator, the 18, the 6, and the 5, by the entire LCD. Didn't change the denominators though, right? And now I'm ready to cancel. So anything that is in common, so the x's cancel, the x minus 3's cancel, the x's there, or I'm sorry, not the x's, the x minus 3's cancel, and here the x's cancel. So now what's left, push pause again and make sure that you get what's left there. Alright, so 18 was left here, minus 6x was left there, and 5 times x minus 3, so 5x minus 15. I added 6x to get positive 11. I should fix that, sorry. And then I added 15 to get 33, and when you divide by 11, you get x equals 3. However, when I put 3 And for this denominator, it makes that 0, so that doesn't work out. So what does that tell you is this problem actually has no solution because the one solution we found was extraneous.